Yeah, hello everyone. So let me wait a few minutes before we begin. And the students who have arrived, can you please write your name in the chat box so that we can begin? And a bit sorry for the delay. There was a bit of technical issue regarding the streaming, that's why. Yeah, and meanwhile, we can wait for a few more students to arrive so that then we can start. Yeah, hello Kamal Oja, hello Satish. Um, yeah, so I have presented my screen as well. And hello, Satish. Is this your first live class? And yeah, one more thing. I would request everyone to kindly write your name in the chat box to mark your presence, and we can begin very quickly then. Sir, hello, Kamal. We will start very soon. We are just waiting for a few minutes so that other students can join. Hello, Sumit. It was supposed to start at 10, but due to a bit of technical issues, I started after 20 minutes. Apology for that. Hello, Sumit. So, how are you, Sumit? Yeah, you can see my screen as well. So let me give you an introduction about what exactly is this series about, and for the students who have joined for the very first time. So this is the seventh session today, and these sessions are basically about graphs and trees for your interview preparation. Okay, so this series is entirely focused from interview point of view. I will be discussing all the concepts related to the graphs and trees, and I will also be taking up famous questions which are very frequently asked in interviews as well. So today is the seventh session, and previously we have covered topics like representation of graphs. Then we have covered topics like DFS, BFS. We have covered topic like multi-source BFS, zero one BFS. We have also covered topic around like bipartite graph. We have also covered topics like topo sorting. These were done in the last class. We covered topics around cycle detection. We covered topics around finding, yeah, cycle detection we covered using both DFS and BFS. We did practice problems as well. Common interview questions which were asked in Amazon and other companies. Okay, so these are the topics which we have already covered, and today will be another practice session. So today we will be practicing two questions. Okay, these questions will be basically from TopoSort, BFS, or a combination of both. So let's look into it. And let me tell you about myself. My name is Gourav Kumar Shaw, and right now I am in my third year at IIT Kharagpur. And apart from that, I am a mentor at Geeks4Geeks, and I am also an incoming software engineering intern at CureFit. Okay, so let us begin with the today's topic then. So, how many people are there with me? We have four people with me right now. So, I would like everyone to kindly interact with me during the session. So, this can help me to deliver much content in a much better way. Okay. So, let's look into today's questions. The first question is named as eventual safe nodes. Okay. So, I'm showing you the Geeks for Geeks question where it's the problem statement, and then we can try to look into its concept and solve it. Okay. So this is a problem statement. Yeah. So Kamal is asking that from where to get internships for fresher. If you are a fresher, you can basically, I would recommend you to kindly focus on improving your skills rather than doing an internships. Because if you get your skills correct in data structures and algorithms and coding, then you can easily get your internships from second year onwards. And meanwhile, you can try Internshala and LinkedIn only to get your internships in your first year. Okay, but I would highly recommend you that you improve your coding skills in first year. Okay, so let us start then. The first question is this eventual save states. Okay, so let us look into this first. The question says that we have been given a directed graph of v vertices and e edges, and it is given in the form of an adjacency list. Now, each node of the graph is labeled with a distinct integer in the range 0 to v minus 1. Okay, so it's a zero-based indexing. Now, the question says that a node is terminal node if there are no outgoing edges, and a node is a safe node if every possible path starting from that node leads to a terminal node. Okay, so two definitions are given here. And the question is asking us that we have to return an array consisting of all the safe nodes of the graph. The answer should be sorted in ascending order. We have to return an array consisting of all the safe nodes. And what are the safe nodes? Safe nodes are those nodes from where every possible path starting from that node leads to a terminal node. And a terminal node is a node which doesn't have any outgoing edges. Okay, so this is the question. So let us look into it. The first is the definition of safe node. Safe node says that if there is any node and if we try to traverse from that node along all possible directions, okay, along all possible directions, then we will end up at terminal node. Okay, and what a terminal node? A terminal node are basically those nodes at which every other nodes are ending. Okay, so all other nodes, in fact, the nodes are ending. Okay, it means that in a terminal node will not give rise to any other node. So if any node is connected to the terminal node, it should mean that it is coming to that node in this fashion. Okay, something like this. But there should not be a directed edge going from that node to some other node. Okay, so this part is not allowed. This is not allowed. Okay, this thing, right? So this is called a terminal node. Okay, and in this question, it is given that our terminal node is this entire graph is basically a directed graph. Okay, it is basically a directed graph. I hope everyone knows the meaning of a directed graph. It means that one node is connected to another node and there's a directed edge between them. It means that this node, if this is U and this is V, U is connected to V. U is connected to V, U to V, and not V to A. Okay, so this is what it means, and let us look into the concept of how we are going to solve. So the question is basically saying us that the count of we have to find the count of those nodes which are safe. Count of safe nodes. Or in fact, not just the count, we have to also output them as well. Output them in ascending order. We have to output them in ascending order. Okay. Sir, your screen is not visible. I think my screen is being shared, right? Can you all confirm? I can see it myself. You can see the Google Jamboard, right? The PDF that I have. Is there anyone who is not able to see my screen? I think, can you just please confirm? I guess, Kamal, it's a problem from your end, maybe. But I don't think so. That should be a problem. Okay, Gaurav, let's continue. Visible, yes. Okay. So, yeah. So this was a question. So we have to count the number of safe nodes, or in fact, we are not supposed to count. We are supposed to output them in ascending order. Okay, so if let's say if my node 1 and 3 are safe nodes, so I will output 1 and 3 in a form of an array. Now let's talk about, suppose if this is our graph. Okay, if this is our graph. Now, how we will proceed? We have to count the safe nodes. Okay, first tell me. So let me say something. Let me say, is the node number 4? Is this a safe node or a terminal node? First, we have to identify terminal nodes, and let us then will identify safe nodes. Okay. So according to the definition of terminal nodes, all nodes should end at that node. Okay, and nothing should begin. I see that node number 5. There are two nodes entering node number 5. Means 4 and 2 are basically entering here into node number 5 and ending there. 5 is not giving rise to any other node. So I can safely say this is a terminal node. Okay, this is a terminal node. Then let us see another example. Uh, are there any other terminal nodes? Can anyone please confirm? Any other terminal nodes are there? Can anyone confirm, please? Hello, Naikaj, how are you? I guess you are coming after a lot of time, I guess. You were there in my previous 3, 4 sessions, but I did not see you in the last 2, 3 sessions, I guess. So anyway, you can continue today. We are discussing a few problems related to topological sorting and BFS. Okay, yeah, you will enjoy those. The first problem is eventual save states. Okay, I am putting the link of this problem in the description so that you all can have a look at it. Yeah. Yeah, so let's continue then. So, are there any other terminal nodes? Can anyone tell me? Let's put a node number 6 here as well. 6 is a isolated node. It means that none of them are connected to anything. Okay, so tell me, is there any other terminal nodes? Anyone? Yeah. So let me tell you that since I have already identified a node 5 as terminal node, now I also mentioned that this node number 6 is basically a isolated node. So it means that this is also a terminal node according to the definition, because terminal node says that it should not it should not produce any other outgoing edges from this node, and in fact it is not doing that also. So that is the reason this is a terminal node. Okay, now we have to find the safe nodes. Okay, and how we will find the safe nodes? Okay, let me tell you, is 4 a safe node? Can anyone tell me, is 4 is a safe node? According to the definition of safe node, we know that any node which is safe, if all the paths from that node basically goes on to a terminal node. If we are standing on 4, we can see that if we proceed from 4, we are reaching up to 5. And 5 is actually a terminal node. And it means that it is going to a terminal node. So 4 is a safe node. Okay. Now let's talk about 2. All the paths from 2 should lead to terminal node. In fact, it is that is the thing that is happening here as well. From 2, there is only one path which can basically go, and that path leads us to 5. Okay. So in that case, we can very easily say that 2 is also that node number 2 is also a safe node. Okay. Node number 2 is also a safe node. Now let's talk about node number 5. Okay, is 5 a safe node? Now we are observing something, that 5 is basically, is there any nodes which is coming out of 5? In fact, there are no node which is coming out of 5. So the condition was that if there are any nodes which are coming out of that given node, it should end in a terminal node. But in 5, there are no nodes coming out. So we can also say that 5 is also a safe node. It is in fact a terminal node as well, but we will also consider it as a safe node as well. Now the next question is 6 a safe node? Yes, it is also a safe node because the same definition again applies here as well. So we have to list down all the safe nodes. So all the safe nodes are basically here 2, 4, 5 and 6. And we have to return this as answer. And before we should return, we have to make sure that this is in ascending order as well. Okay, so this will be our output array. Now the question arises, how are we going to solve it? What concept are we going to use to solve this question? Anyone? So can anyone tell me a small gist of how exactly we will be able to solve this question? Can anyone tell? Hello Naikaj. Hello Sumit. Maybe find a cycle. Gaurav is saying find a cycle. Okay. Sumit is saying topo sort. Okay. Um, let's see. Okay, Gaurav, are you saying find a cycle? Is there any cycle in this graph? You know, you all can see that there is actually a cycle in this graph. If I move from node number 0 to node 1 to node 3, and node 3 to node 0, there is a cycle actually. So do you know that the question was to find a safe node? And can anyone tell me, will 1 ever be a safe node? Will 1, or in fact any node which is a part of a cycle, will it ever be a safe node? Because if I'm starting from node 1, I am basically going in circles and circles in a loop. So the idea of safe node was that if any node is beginning from that node, it should end to a terminal node. But what is happening here? It is basically going inside circles. Okay, and any node will not also not be a part of a terminal node as well, because terminal node, what happens? Every node is ending at any given node, but that doesn't happen in a cycle. In cycle, it forms a continuous loop, and there are no start or no end. So basically, what we can assume is that any node which is a part of a cycle can never be a safe node, or in fact, it can never be a terminal node as well. So, did you all understood this concept? Naika was saying topo sort, maybe find a cycle. Yeah. Hmm. So, no, we will not be applying the concept of topo sort here. Uh, Basically, what this question is related to the cycle detection part. Okay. So, sometimes you have to understand. Like I know that somewhere it was given that you have to written in ascending order. So maybe you thought that topo sort can help us. But actually, what is happening here? Observation. We have to do certain observations. The observations are The observations are basically that if any node is a part of a cycle, then that node cannot be a safe node. And that node cannot be a terminal node as well. Also, if anyone who is a part of the cycle and cannot be a safe node, this is one. This is the first point. The second point is, or if any node which is not a part of the cycle, but that node is basically leading to a cycle. In that case, that node will also not be a part of a, that node also cannot be a safe cycle, safe node. Okay. Let's see an example. Let's see, this is 1, this is connected to 2, and then this is connected to 3, this is connected to 4. Okay, and this is connected to 1. Let us say there is another node 5 which is connected like this, and another node 6 which is connected to 5. Okay, so in that case, can anyone tell me whether 5 and 6 will be a safe node or not? Can anyone tell? Okay, Naikaj, no problem, Naikaj. I have already given the link in the description, in the chat box only. You can just check it out. Okay. So I was asking that, will 5 and 6, can anyone tell me, will 5 and 6 be safe nodes? Can 5 and 6 become safe nodes? Okay, I guess my mic was turned off. Really sorry about that. I don't know, some issues are there. Maybe this was same in the last session as well. In between, due to some problem, it got turned off. But no worries, I'm explaining it again. Yeah. So basically, I was explaining the approach of what exactly we are going to do by with the help of a DFS. The point was that we have to detect a cycle, and the second point was that we will be discarding all those nodes which are part of a cycle, and at the same time, which basically leads to a cycle. Okay. So what we will do, we will declare three arrays. The first will be a visited array. The visited array will help us keep track of the nodes we are visiting. The second array that we will declare is of the path visited array. This will help us detect that whether there is a cycle in the array or not. Okay, just according to the rules of BFS. And we will also keep a check array that will help us find the safe nodes or not. Okay, so according to the discussion, according to the rules, what we will do, we will call for the DFS and we will check that whether an adjacent node is visited or not visited. If it is not visited, we will make a new DFS called recursively with that particular node. And if the adjacent node is visited and it is also on the same path, it means that there is a cycle. If it is a cycle, we will just return true. Okay, then there is no point doing the DFS again. We will just return true. Yes, there was a cycle. So let's not include it in our check function, in our safe node function. And if the other node is visited, but it is not on the same path, it means that someone else came and made it visited, but it is not a part of a cycle. Okay. So in that case, what we will do, we'll mark it as visited in some other part and not the current one. So there is nothing to do in this way. And finally, when there are no nodes to visit, we will mark the nodes as safe in the check array and unmark the current node in the path visited array and return false. Then we will backtrack to the previous node with the return value. Okay, so basically what we are doing here is that we mark both the nodes as path visited and visited as true, but at the end of traversal to all the adjacent node, we make sure that we mark the current node safe and unmark the path visited and still keep the visited marked as true, as it will avoid future extra traversal. So that is what we are doing. Okay. I hope everyone understood it. Okay. So let us do a dry run first. Okay. How will a dry run help us? I'm showing you how. Okay. So what we can do here is that I have already drawn a graph in my previous slide. So let us try to do this. So let us see that we are starting a DFS call from node number 0. Okay. So when we are starting a DFS call from node number 0, what it will happen? Then it will mark all the node visited and path visited from 0 to 1, 1 to 2, 2 to 3, 3 to 5, 5 to 6, and then 6 to 7. Okay. As there are no further nodes to visit after 7, it will backtrack to node 3, and meanwhile it will mark node 7, 6, and 4 from path visited area and also mark them as safe nodes. Okay. So after our entire DFS traversal happens, we will see that these nodes are basically the safe nodes because these are not a part of our cycle and they are not leading to any cycle as well. Okay. So I hope everyone knows about the code to understand how the path traversal works. Okay. So let's yeah. So what I will be doing now is basically helping you solve the code here. Okay. Just according to the rules that I just mentioned. So the first step was to declare three arrays, and we will be declaring three arrays. The first array will be a visited, the next array will be path visited, and the final array will be a check. And we will also keep a answer variable called safe nodes. With the help, we will basically see whether it is a safe node or not. Okay, and then finally we will just return it our safe nodes. Okay, so this is the code for that purpose. The three nodes that we have declared. This will help us store the safe nodes, and this will help us return the safe nodes. Okay. So this is done. Okay. So now let us talk about other few things. Yeah. Let's see the. Okay. So this is basically n- the code for getting started. Now we have to write the DFS code. Okay. So what exactly will be the process to write a DFS code? Will be basically. Let's see. Let me just paste it. Then I will just continue. Yeah. So let's see the DFS code. So what exactly was the DFS code doing? Basically, it was doing yeah. So the DFS code was basically doing, the first thing it did was it accepted the node from where we are starting our DFS. Then it accepted the adjacency list from where we will continue. Then it accepted the visited array as well. And after it also accepted the path visited array as well. And finally, we did the check array as well, because that array is keeping track of all the safe nodes. The first and the most important thing is that we will mark the visited node as true, and we will also mark the path visited node as true. After we do that, hmm, we will traverse all the adjacent node, and then we will check whether that node is visited or not visited. If that node is not visited, in that case what we will do, we will call the DFS function. And if it is a DFS function is equal to true, in that case what will happen, we see that node has detected a cycle. And then what we will do, we will just put that node as 0. Check of node is equal to 0. It means that node cannot be our safe node. And then we will return true, that yes, we have detected cycle, so let's go back. Okay. Now, after that, what we will do, we will write a else path, and we will see whether the path visited is true or not. If it is path visited is true, it means that there is a cycle, and then we will return check node. We will put 0. It means that that particular node. Yeah, so it means that that particular node is not a part of our visited array. Okay, so not a part of our safe nodes, and then we will return true. And finally, before we are ending DFS, what we will do, we will if that node is if we are reaching here, it means that node is part of our safe node, and then we will mark that safe node is equal to 1. And if that node is, and since we will also unmark the path visited as well, because we are coming out of DFS. So let's make it 0, because any node part of a cycle basically is due to the presence of the fact that a DFS traversal is done. And when the DFS traversal is done, we basically unmark it to 0 for future traversal to happen. Okay. And if we would have kept it marked as 1, then in that case, we won't be able to detect a cycle in the later DFS call. That is the reason we are doing this. Okay. So let us submit this code and check whether it is correct or not. And in fact, if you have any doubts, I would request you to kindly ask in the chat box. Yeah. So as you see that all the test cases have passed, so therefore our code is correct. So any doubts? Yeah. So Sanu was saying that we can reverse the edge and apply the topo sort algorithm. Yes, Sanu, this algorithm with this type of concept will also work if we try to do it. Okay. But I wanted to discuss the DFS part. That is the reason we did. You can apply the Khan's algorithm to do it in the way of BFS. So what will happen is that you can take this as a homework and try to implement the topo sort algorithm to solve this question. Okay. So, and basically what happens is that Khan's algorithm is one of the algorithms that help us detect cycle. And the concept was lying here is that we have to detect a cycle in the graph. Okay. So whether you do it by DFS or by BFS by using a Khan's algorithm, so both the concepts, the core of the concept remains same. That it should not be a part of the cycle and it should not lead to any cycle. Okay. So that is the basically the concept that I was trying to highlight. Okay. So I hope everyone got the idea. So let us continue then. This was one question. Yeah, so let us continue for the next question and see what exactly we can do. Hmm. Okay, so let's see the next question then. The next question will be about topo sorting. Okay, so yeah. So in the last session, what I did was I discussed the Khan's algorithm in a small brief. Okay. So I did not discuss it the code. I just gave the concept and I told you all that to see the concept later onwards by yourself. Okay. So what we will do here is that now I will be showing you the BFS algorithm or the Khan's algorithm for the topo sort. Okay. So I'm pasting the link in the chat box at the same time so that you can follow. Okay, so let's continue then. Hmm. So this is a link for the TopoSort, and let's have a look at it. This one, yeah. So yeah, in the previous session I discussed how what exactly is the concept of topological sort and how we are going to solve it using DFS. But this time I will be discussing about Khan's algorithm or called the BFS algorithm. Okay. So the Khan's algorithm was already discussed previously. So in this session I will be discussing about how to write the code of Khan's algorithm. Okay. I already mentioned the steps of writing the code. Let's have a look at it. Hmm. Okay, so this is the code for the DFS approach that we had used previously. So let me comment it out so that it stays on the screen. This was I solved it in the last session. Okay, so now I will be showing you the code for uh, writing in the way of this. Okay, so what exactly we will do here? The first and the most important thing is that we have to find the integrity of our graph. And what exactly an integrity means? Integrity means that the number of nodes, which are basically the number of edges which are basically coming into a given node. So, and we will fill that. Okay. So this nested loop is basically calculating the integrity for all the nodes. Okay. If there is a directed edge between a node and its adjacent node, we just increase our integrity by one. This is what we are doing. Then we have to write a Q data structure. And that Q data structure will basically help us perform the BFS part. Initially, we are putting all those nodes in which integrity is equal to 0. And integrity equal to 0 means that all the nodes are basically coming out from that node. Okay. Okay, integrity. So none of them are coming, none of them are coming inside that node. Everything is going out. So it means that that node should be placed in before any other node because what is the definition of topo sort? The definition of topo sort says that all those nodes which are basically connected to any other node, those nodes should come before, and the node which are connected to it should come after. So that is the reason we are initially pushing those nodes which are connected to which are basically having integrity 0. Then we will keep a vector topo, which will help us get the topo sort. Then we will perform our usual BFS algorithm. In that, we will write int node is equal to q dot front, and we will take our node, we will pop that, push it into our topo sort. And then what we will do, we will go to each and every adjacent node of our current node, decrease its integrity by 1. And if the integrity becomes 0, we will push it into the queue so that we can print it in our topo sort. Okay, and finally return our topo sort. So this was the concept for finding the topo sort of a given graph using Khan's algorithm or by BFS algorithm. Okay, so as you can see that all the test cases are passing, so therefore this concept is correct. Hmm. So actually I discussed this concept in my previous session. You can watch the recording there. But I did not. The time was over, so I did not code it. So this is a code related to it. Okay. I hope everyone got it. Hmm. So let's talk about the next part. Is there any doubts here? Hello Gaurav, are you there? Hello Sanu, are you there? Hello Sumit. Hello Aditya. Okay, so any questions do you have till now? We discussed about two important things. The first was topological sorting, and the next question was to detect a cycle, and then find the number of safe nodes and return the safe nodes of a graph. Okay. So now, what else? Okay, Gaurav, no doubt. Sumit, yeah, sure, Sumit. Let's continue then. Okay, so this part is done. So the next thing that I was trying to do here is that detecting a cycle. Okay, by using toposort. How we will do that? The first question was also will be involved in this concept only. The first question also involved. If you're trying to do by toposort method, then in that case we had to somehow use that. Okay, so let's see. Yeah, I'm pasting it in the chat box. The question that I'm discussing. So this question involves us detecting whether there is a cycle in our graph or not by using topological sorting. Okay, so by using BFS algorithm or making use of toposort. Okay, so how to do that? Let's see. Does anyone have any idea how can we use topological sorting to detect a cycle? Okay, Gaurav, you are saying that never understood the concept clearly, not in the previous session. So you did not understood the concept of toposort, or you did not understood the concept of finding or the Khan's algorithm. Which one? Like the concept of toposort, like we did toposort using two DFS we did, and today we did using BFS. Okay, the Khan's algorithm. So I would recommend you to kindly watch that again. And in fact, what I will do here, I will just give a short introduction so that we can continue with the session. Okay. So the idea of toposort was that if there is any node, let's say U and V, okay, and U is connected to V in this way, it means that in our final ordering, U should come before V. Okay, this is what toposort means. If a node is connected to any other node, that particular node should come before the given node in the toposort final. And there can be multiple toposorts, multiple valid toposorts for a given answer. And toposorts are only available for directed acyclic graph. Why directed? Because I am saying that U should be come before V. And if it was undirected, it means that U is connected to V, V is connected to U. Then U should come before V and V should come before U. And that is not possible. So that is the reason it should be directed. It should be acyclic because if it comes a cycle, then we do not know which one should come before, which one is connected to which one. Then again, we will get into a loop. So we do not want that. That is the reason topo shot is always preferred for a directed acyclic graph. Okay. And what did we do in case of Khan's algorithm? We basically counted those nodes which had an in degree zero. In degree zero means nothing is entering in that node. Everything is going out. So if everything is going out, it means that this node should come. The value of this node should be the first element of our toposort because all the nodes are connected to this node. Okay, so basically these nodes should come after this node. So I should place this node before. So that is the reason initially we were putting all those nodes which had a degree of zero in our queue, and then we were processing it. And as we were processing it, so we were processing this node because it is in our queue. Then after that, we will go to its adjacent nodes, these nodes. And what we will do, we will decrease the we will decrease what we will decrease um, the in degree by 1. And when the in degree becomes 0, we will again push it into the queue so that it can again come up into our topo sort answer. So this was the concept of topo sort. Now the thing is that we will be applying the concept of this concept to solve to detect cycle, to detect cycle. And let's see how to do that. Okay, so yeah, let's see that. Now we know that topo sort. Now we know that topo sort is only possible for a directed acyclic graph. Topo sort is only possible for a directed acyclic graph. So if we try to apply Kahn's algorithm in a directed cyclic graph, we will not be able to find the topo sort. Okay. So basically, let's say we apply Kahn's algorithm to a directed cyclic graph. In case if we are applying it to directed cyclic graph, whatever answer we will get, this will not contain all the nodes. Okay. So what we will do, a directed graph that contains a cycle, it will fail to find the topological sorting. So finally, we will check the sorting to see if it all contains all the v nodes or not. If the result does not contain all the v nodes, we can conclude that there was cycle. Okay. So let's say if there were n nodes in our graph, and if it was a directed acyclic graph, what would have happened? It would give me n nodes in my topo sort as well, n nodes in my topo sort as well. But if it is a direct cyclic graph, this will give me less than n nodes in my topo sort. And then I will count all the nodes. If it is less than n, we can say that yes, there was a cycle in there was a cycle. We have finally detected cycle. So what exactly we have to do here is that all we have to do is apply the Kahn's algorithm and count the number of nodes we are entering into our topo sort array. If that is not equal to n, or in fact if it is less than n, then we can say that yes, there was cycle in my graph. So did you all understand this concept? So, Gaurav, did you understand the concept of how we can detect a cycle in a directed graph? So, let us see this. Yeah. So now I will be doing the code. Hmm. Okay. So, this is the code of this is the directed graph cycle. Okay. We already had yeah. So the code is already mentioned here. Yeah. So this is basically the in degree set, in degree array. Initially, we are putting all the values as 0. After that, we are going across all the nodes of our graph and increasing the in degrees accordingly. Okay. Then we are declaring a queue. This queue will help us perform the BFS algorithm. After that, we are checking all those queues which had in degree equal to 0. If the in degree was equal to 0, we are just simply pushing it inside our queue. Okay. After that, we are doing int count equal to 0. Okay, to count the number of things we are pushing inside our queue. Finally, we are running a while loop. This while loop will help us count the number of nodes which are basically included in our topo sort. Then what we are doing, we are going across the adjacent node, and the process is the same. We will decrease the in degree, and if the in degree becomes 0, we'll push it inside our queue. And at the same time, we will do count plus plus also, just to keep a count there as well. And then finally, after this BFS is over, after this while loop gets over, we will check whether this count is equal to V or not. If it is not equal to V, it means that yes, there was a cycle. So this will return true. And if it was equal to V, then this should return false. It means that there was no cycle, because Kahn's algorithm is only valid for those graphs which are not cyclic, which are acyclic in nature. Okay. So let's submit this code and check. Yeah. So as you can see that all the test cases are passing. So therefore, this question is correct. So any doubts do you have? Any doubts? Hello Sumit, hello Gaurav. So any doubts related to, so we discussed three things in this session tonight. We discussed about topological sorting, how to do that using Kahn's algorithm. We also discussed how can we detect a cycle in a graph, in a directed graph using Kahn's algorithm. And after that, the initial question that we discussed, that was basically cycle detection using DFS. So the question was that we had to find safe nodes. Okay. So the question links are mentioned in the chat box, and in fact, you can just Google up the chat link, and then you can easily find the question link as well. Okay, and the slides are already there in the description of this chat. And apart from that, let me just give you a small introduction for the students who have joined late. So this is basically the a graph and tree series, and this will continue well into the month of January as well. I have increased the number of sessions so that we can cover more and more questions. Okay. So initially we are trying to cover the easier parts, which involves discussing the questions and taking the topics. But after that, we will be covering mostly questions around. Okay, we will discuss two problems on every session. By the end of January, all forms of questions that are involved in interviews will be done related to graphs and trees. Okay. So, and we are meeting on every alternate day at 10 p.m. Okay. So today it was a 15-minute late due to some technical failures. So we are more or less meeting on every alternate days for the month of January. Okay. For the month of December. Okay. So okay. So if there are any doubts, you can kindly ask me right now, and then we can wrap up our today's session. I would request everyone to kindly attend this session. Now, this can act as a very you can basically learn a lot of things from these sessions, and at the same time this will help in your interview preparations as well. Okay, so and later in this session, after a few more sessions, we will be discussing only interview questions. Okay, the questions that are asked in interviews last year, so we will be discussing those questions only. So in that way this will help in your preparations as well. Okay, now in the last session, I basically discussed a question related to graph, which was personally asked to me in my Amazon interview. Okay, and the company in which I will be interning in the next summers, the that company basically asked me a question related to a topo sort. Okay, so as you can see, these topological sort was a very interesting problem. Okay, so this you can know about topo sort, and they actually asked me to implement Kahn's algorithm, BFS algorithm, to of Roposort. Okay, I hope this just gives you how important these topics are. So let's wrap up this session. So a very good night to everyone. Let's meet in the next session. Okay, bye bye.